but it together with this device, which is the amplifier and transducer. The transducer's job is to transform any kind of force into voltage.
Yeah.
Therefore, you measured always voltage. This one, the next part of it, as you can read, the transducer amplifier. Of course, it has an input and an output. The input comes from the measuring device. As a transducer, it transforms it to voltage difference, and then if you set a higher amplification, it amplifies your sign. The bullshit is that, of course, it has advantages and disadvantages. The advantage is that the amplification makes higher differences, and it's good because the sensitivity will be higher, but it also amplifies the noises, which overall actually makes harder the evaluation. Okay, so this is the amplifier, and then you have to talk about how to balance the amplifier. It means that if it's balanced, it measures the best, and if it's balanced, it can measure the positive and negative changes the same way. It's balanced if none of these two LEDs are lit, so none of these should be. If you want to make it balanced, you have to use these pop meters. This is the fine and this is the rough one. You have to set it right with the fine, like if the left one is lit, the arrow shows you have to turn it to the right, but it has a limit. Then it stops, you cannot do it more. Then you set this one to the right, as the right arrow says, you have to rotate to the right, but then you may have to rotate the fine left, okay, because it's too much, this one. So this is how to make it balanced. And then the bullshit continues with the next part. The output sign, the amplified output, goes to the computer, and the computer is just simplifies our jobs, because you have, of course, your changes were in analog scale, so there is no limit of changes like between 1 and 2. But in this case, the computer has digital signs, so you have differences. You can set it, but for example with the sampling rate, you can set it like 1 Hertz. It means that you will collect values of the measurement once a second. But if you set it to 100, you will have like 100 measurements per each second. Then what is this computer for? To show your data, to store your data, and to analyze your data. And by the way, you can print your data as well, and so on. So this is the computer part. It's also a part of the device. So the measurer, the transducer, amplifier, computer, and a lot of bullshit about what is a transducer, how to balance the amplifier, what is the disadvantages of amplification, and what is the computer used for. And then they may ask you to analyze something. And actually, it's pretty much the same what you have to do in these two cases, because when it asks for demonstrate the effect of, for example, barium or calcium or magnesium on the right uterine muscle, your job is to do the experiment as you did yesterday.
Yeah.
And then you have to open your data and analyze it. Okay, so you know how to analyze. I show you the analyzation.
But this program will work on the normal computer?
No, because for this you have to run at first very special National Instrument Lab View program, and then the simulator program, which is not published unfortunately. And the problem is that if I try to use it on other kind of computers, it didn't run, because it's especially for these kind of screens. Look at this. If you have smaller screen, trust me, you cannot see the wall part. So for example, in a normal 13.3 laptop, you can see only this part, and you can do nothing with it. So if you have if they ask you in this case the fourth topic to analyze something, or after the fifth or sixth experiments, you have to input your previously saved, or they will ask you to open the sample. It's do you remember? It was sometimes if you open your data, you cannot see just a really small part of it. 1 second.
We can change the zoom, right?
Yeah.
The
In
middle
this case,
one.
you have to, the second, the middle one, and then left bottom. It will allow you to see the wall experiment, the wall curves. And then they will ask you to show me how can you measure the amplitude of each contraction. Then, for example, for this, you put I think it's better to use the green as the first. You put the green marker in the beginning of contraction and the red at the end. And then amplitude is the greatest difference between the green and red markers, so between this point and this point automatically. So amplitude is the highest difference. It's always the highest force.
For finding a slope is also like this, or
Yeah.
which is
Slope, time to peak, integral, you have those things. If they ask you for example, cycle length, then delta x is your cycle length. Sometimes they ask you not to, because if you can see the curves for storing, is what you have between the two markers, then you can really easily see that whether you are at the end of the contraction or not. I think here is the end. But sometimes they calculate cycle length at the difference of two identical points of two neighboring contractions, like these, the peaks. The peak is the most easy to find part of the contraction wave, and then delta x will be the cycle length. But the hardest is the HRT, as you remember. Do, for example, this one. So the major points, how to set the markers. In this case, the first marker should be at the top of contraction, So the beginning, let's look at this as well, the beginning of relax, maybe here. So then you put at the beginning and the end of relaxation. Then you read this number, negative 0.015. We can zoom in with the second option. In this case, we can set manually the region we want to focus. Then we have to set the first again, because we have to change the position of the markers, the second one actually. So we have this number, negative 0.015, as a reference number. And then, we should move the second towards the first till we see this number, negative 0.15, as its y value. So we should see this number here. But when I change the position of this number will change. Do you see? So this should be negative 0.015. It's here. So then, delta x is HRT. HRT is the half relaxation time. Note, this is the relaxation. HRT, the half relaxation time, is not just is not the half of this, the relaxation time, but the time which is needed to reach during the relaxation the half of the maximal relaxation. And this is delta x in this case. Okay, did you understand what I said? Okay. So the first point, set. Listen, I think it's easier if you just zoom out and initially zoom in that region you want to use. Okay, for example, this contraction wave. Then the first, put at the end of relaxation, then read negative 0.15, change the position till you see it. So the time which is needed to reach that change, that relaxation, to get the half of the whole relaxation, is 7.5 seconds. This is the half relaxation time. Okay, and now just discuss the next two topics. Demonstrate the effect of barium and papaverine.
This one has finished, right?
Sorry?
This one has finished.
Yeah.